So let's open up section 6.3 on metals, nonmetals, and metalloids. Actually, I guess this one's just about metals. So most of our periodic table is metals. The majority of the elements are metals on there. And so all we're going to do today here is we're going to look at their physical and chemical properties, and we'll look at sort of what makes a metal and how it differentiates it from a non-metal. And these things are important too for sort of future lessons here. So I've got 6.3 up on my screen. Hopefully you can see it. So metals, why do fighter jets, racing bikes, and artificial hips have in common? Figure 1. They all have metal parts. Metal is used in many different kinds of products. As well too, when we're reading this here, there's always these definitions on the side that are kind of helpful, and we'll sort of go back to those as well. So properties of metal elements. What is a metal? Metals are usually shiny. They're good conductors of electricity and thermal energy. This property is called conductivity, so they conduct heat or electricity. Except for mercury, they are all solids at room temperatures. Most are malleable, which means they can be hammered into different shapes, and ductile, which means they can be pulled into long, thin wire. And most react with acids. And some examples are gold, silver, potassium, calcium, copper, tin, iron, and lead, excuse me. And again, you look at your periodic table, you're probably looking at 80 plus metals that are on there. Metal mixtures. Most metal objects are mixtures of metallic elements from the periodic table. Stainless steel, for example, is a mixture of mostly iron, nickel, and chromium. The addition of nickel and chromium makes stainless steel almost rust-proof. A metal produced by blending different metals together is called an alloy. Brass, for example, is an alloy of the metal elements copper and zinc. Bronze is another alloy that contains copper. In this case, the alloy is copper mixed with tin. Designer metals, jewelry. Metals have many useful properties, which is why they are used so often. Gold and silver are the main metals used to make fine jewelry. Gold's color and luster makes gold jewelry desirable. However, pure gold is too soft to be used for jewelry. Instead, pure gold is alloyed with other metals like silver and copper to harden it. Art. Glass blowers and artists who work with glass use different metals to create rainbows of glass colors. Everyday uses. Metals such as gold and aluminum are so malleable that they can be hammered and rolled into foil. Copper is prized for its ductility and electrical conductivity. Copper is ideal for electrical wiring because it's an excellent conductor. It does not corrode easily, and it is inexpensive. Special uses. Metals have many other uses, some of which might surprise you. For example, the torch of the Sydney Olympics in 2000 was carried underwater for 3 minutes along the Great Barrier Reef. To remain lit underwater, the flame had to be extremely hot. The fuel used to produce this flame was a mixture of oxygen-generating chemicals and finely powdered magnesium metal. Hidden hazards. Metals are very useful, but they can cause problems. Nickel is often used to make the posts and wires of jewelry worn in pierced ears. Many people are allergic to nickel and may experience painful rash that can lead to infection if the rash is scratched. The term heavy metal is not just used for a type of music. Some metals, such as mercury and lead, are very dense or heavy. Mercury was once widely used in mining and industrial processes and frequently found its way into the environment. When foods containing mercury or lead are eaten, internal organs such as the brain can be damaged. Lead is often mixed with other elements to produce strength and durability. For example, leaded glass breaks less easily than plain glass. Leaded crystals is composed of up to 24% lead. Some of the lead can dissolve in acidic drinks such as fruit juices because metals often react with acids. And the plumbing of many older buildings is made of copper pipes held together with solder that contains lead. Both copper and lead are toxic, and both dissolve more readily in hot water than cold water. This is why hot water from the faucet should never be used to cook food. Okay. So that's metals. So we'll summarize all this stuff in a little bit here. For now, let's go back to our homepage and let's get 6.4 on nonmetals. Now, what we're about to learn about nonmetals here is that essentially their properties are exact opposite of those of the metals. If you look on your periodic table, the nonmetals are opposite of the metals. They're on the right-hand side, whereas the metals are on the left-hand side. So I'll give you a sec to open that up so you can follow along. So non-metals. You can follow along or you can listen to me read it and watch, whatever you prefer. Metals far outnumber non-metals on the periodic table, and yet well over 90% of all known substances are made of only non-metals. This means that the majority of things around you, including your body, contain mostly non-metals. I'm just looking at figure 2 here for a second. It says 95% of the mass of the human body is made up of non-metals. You can see we've got 65% oxygen, 10% hydrogen, and then some trace other elements there, mostly the non-metals. And again, if you look at this picture, figure 1, really, we don't even look at all the non-metals. This last group here, they're fairly unreactive. It's mainly just sort of these 10 that are really found and used every day. So properties of non-metal elements. What is a non-metal? Many non-metals are gases at room temperature. A few are solid and one is liquid. Solid non-metals do not have the metallic shine of metals. Most have a dull luster. Some, such as sulfur, are brightly colored. Solid non-metals are brittle, which means they break or shatter when bent or struck. Non-metals are usually poor conductors of heat, electricity, and thermal energy. Some examples are carbon, sulfur, oxygen, chlorine, iodine, and neon. So we'll get pretty used to using these ones coming up. A solid non-metal. Sulfur is a brittle, a bright yellow solid. Sulfur burns with a blue flame to produce sulfur dioxide. In nature, sulfur is often found deposited at the edge of hot springs and geysers. It is also found around volcanoes. Links between sulfur atoms within hair proteins are what make hair curly. Sulfur is often used to make important industrial chemicals like sulfuric acid. Non-metals in the air. Most gases in the air are non-metal elements. The composition of air is 78% nitrogen, and that seems really high, but that's really just because nitrogen is unreactive. 21% oxygen. If you think about it, flames and fire need oxygen to burn, so our air is 21%. So if we had a higher concentration of oxygen, then flames would burn very brightly, perhaps even burning out of control. And about 1% argon, and there are some trace elements in there as well. Water vapor itself kind of varies in the air we breathe. Depends where you are on the planet Earth. Like if you're on a tropical island, you probably expect the water percentage to be higher. And if you're in a drier climate, possibly like Thunder Bay right now, it's probably lower than what it would be at those tropical locations. So anyway, oxygen is the gas all animals need to breathe. Recall that in chapter 2, the green plants reverse oxygen into the air during photosynthesis. We haven't learned that yet. Nitrogen makes up 78% of the air we breathe, but we do not normally notice it. However, nitrogen is the compressed air that scuba divers breathe, can cause some serious problems. As the diver goes deeper, the amount of nitrogen dissolved in the diver's blood increases. Surfacing too quickly causes bubbles of nitrogen to form in the diver's blood. This can result in pain, dizziness, loss of feelings, or even death. If you've ever watched TV shows, the divers can't stay down forever. They only have a certain amount of time before they have to come back up because of this nitrogen problem. To react or not to react. The last two groups in the periodic table are nonmetals that have very different properties. Group 18, halogens. Halogens in group, I said 18, but it's group 17. And we're actually going to call it group 7. In our textbook calls it group 17, and that's fine. So the halogens in group 17 are fluorine, chlorine, bromine, iodine, and acetylene. All of these elements are highly reactive. Fluorine reacts explosively with hydrogen to form hydrogen fluoride. In water, the substance makes hydrofluoric acid, which is used to etch glass. Pure chlorine, bromine, and iodine are poisonous to living things. Chlorine is used to disinfect water for drinking or swimming because it kills bacteria and other pathogens. Bromine has a wide range of uses, including dyes, medicines, pesticides, and photography. Iodine dissolved in alcohol is used to disinfect wounds. Campers often use iodine tablets to make water safe to drink because iodine kills bacteria. Another common use of these elements is in halogen lights. These lights are very bright and also give off a great deal of thermal energy. This property makes them potential fire hazards. So that's group, it's the second last group. And the very last group, on the far right side of our periodic tables, we're going to call it group 8, but our book calls it group 18, are the noble gases. Unlike the halogens, noble gases in group 18 rarely react. But this does not mean they have no uses. Balloons filled with helium rise because helium is less dense than air. Neon is used in the bluish high-intensity headlights of certain vehicles. Neon and argon give off brightly colored lights when electricity is passed through them. This makes neon and argon useful for decorative lights. So there are your non-metals. And again, we're going to summarize all this stuff coming up. Now, in between our non-metals, and hopefully you can see this picture right now. You've got the green ones here. These are the metalloids, and there's only 6 or 7 of them, depending on the periodic table you're looking at here. So let's read about the metalloids, and then we'll get to our summary note here. So this is a much shorter section, being that there's not as many metalloids out there. So metalloids, part metal and part non-metal. Only a few elements in the periodic table are classified as metalloids. There are even fewer in number than the nonmetals, but they have some have very useful properties. Properties of metalloids. Metalloids have properties in between those of metals and nonmetals. All metalloids are solid at room temperature. Some metalloids are weak conductors of electricity and thermal energy. Examples are boron, silicon, germanium, and arsenic. Semiconductors. Metalloids play an important role in the electronics industry, figure 2. Some of the metalloids conduct electricity to a degree. This property makes silicon and germanium useful to make semiconductors. Semiconductors are also used to make parts of electric circuits in electronic devices. The flow of electrons in a semiconductor can more easily be controlled than the flow of electricity in a conductor such as copper. This property makes it possible for computer chips to do complex tasks. A toxic element. Arsenic was once the most famous metalloid. Like many other of its neighbors in the periodic table, arsenic is toxic and has often been used as a poison. While poisoning people with arsenic may be the stuff of old detective novels, this element still has harmful effects today. Arsenic was used in industrial processes. It was used as a wood preservative for outdoor building materials and as an insecticide on fruit trees. As a result, it has escaped into the environment, contaminated soil, water, air, and food. Although it is no longer used as a wood preservative, many older outdoor structures such as decks, picnic tables, and playground equipment may be hazardous. Okay, so there's lots of info, so we're going to summarize this. So grab a piece of paper or open up your Word file or whatever you do to take notes here. And that's what we're going to do. So 6.3 to 6.5, we've got metals, nonmetals, and metalloids. And I'll give you a second here to get sort of caught up. We'll split this up into 2 parts. And our first part will be the physical properties. So we learned about physical properties a couple of days ago. And so this is stuff that we will be observing with our senses. Now, actually, one other thing maybe we should add in here is we're talking about metals first. So sort of a couple of subtitles here. Okay, so we got metals, and we'll talk about their physical properties first off. So really all I'm asking here is if you had a chunk of metal in your hand, what would you think about it? So in no particular order, you'd probably think that it was shiny or gray in color. And I'm talking metals in sort of their purest forms. And we're not talking about the alloys, brass or things like that. We're talking about ones you can find on the periodic table. Yeah, heavy. Thanks. Yeah, so if you're holding on to it, you would think it would be heavy or dense. And most metals, if you put them in water, I say most metals, you put them in water, they're gonna sink to the bottom. There are some metals that would actually float around on the water, believe it or not. So some are a little less dense, but they're also reacting with water at the same time. So shiny or gray, heavy or dense. Probably most of them are solid, except for mercury. I don't want to type out mercury. If you find mercury on the periodic table, I think it's like number 80. It's got a symbol of Hg. So I'm just going to put Hg for mercury. So that one is solid at, they're all solid at room temperature except for liquid mercury. They are hard. So you can't scratch a metal very easily. I mean, it can be done, but it takes some effort. And this one actually sort of leads us to another one. So because they're hard, metals have high boiling points and melting points. Like it takes a lots of energy to change it from a solid into a liquid, maybe thousands of degrees. So let's say this. Let's say high boiling and melting points. An important one too is they conduct heat and electricity. That's a pretty decent list we have there. You guys think of any other ones? All right, I'm pretty happy with that list. So those are some physical properties, things you can observe. So let's talk about some chemical properties here. And these would be found through experimentation. So there's a couple of typical experiments that we can do with metals. So we ask ourselves, do they react with water? And yeah, they actually do. So they can react a couple of different ways. They can, so believe it or not, some metals will actually like start to form hydrogen gas. They'll actually explode. I do have a nice little video on that. They can also rust. So let's say this. Let's say they react with water to rust. So you leave a metal outside, eventually it's going to rust. They're also going to react with oxygen. Like silver will tarnish. So we say they oxidize. Let's just say react with oxygen to tarnish. So when silver tarnishes, all that means is that, it's no longer shiny silver. It gets to be dark and dull, and even there's black stuff on it. Again, that doesn't necessarily apply to every element, but we can still put it. The last one is they react with acid. Form hydrogen gas. And I think they did mention that in their readings. And that's just kind of a typical science experiment. If we were in the classroom, we could take some metal and put it in different kinds of acid, and you'd see this hydrogen gas flying off it, if you will. So that's about it. So metals are fairly reactive, which is a nice property. And now we'll transition on to the nonmetals. The thing about the nonmetals is all their properties are essentially opposite of the metals. So what might make it easier maybe on us here is if I do a side by side. No. Maybe we'll just stick with it. We'll just jump back and forth. It might be a little easier for you guys. Okay, so but anyway, let's talk about the nonmetals next. Here's what I'll do. I'm going to copy and paste this and then just kind of change it as we go along. That's cheating, but I'm doing it. Okay, so nonmetals. you can write nonmetals, you create physical properties, and then we're going to change all these ones. We're going to sort of make them opposites. So we said that metals were shiny or gray, essentially. When we get the nonmetals, they're actually very colorful. They mentioned sulfur in our textbook, which was yellow. You got chlorine gas that can be green, bromine, and iodine can be brown, red phosphorus, white phosphorus. There's a whole bunch of different ones. So instead of putting shiny or gray, we're going to put colorful. And that's spelled properly. So we got heavy or dense. Well, they're actually light and brittle. Well, and they could be solid at room temperature, but they could also be a gas or a liquid. So let's put all three states at room temperature. Room temp. Room temperature. Metals were hard, and these tend to be soft. And that's where brittle and light, I guess, could also come in. And our last 2 points are also opposites. So metals had high boiling points and melting points. Well, these ones actually have low boiling points and melting points. Usually I just say BP and MP for boiling points and melting points. And we can prove that by the fact that right now you are breathing in nonmetals. They're in the gaseous state, right? Oxygen, nitrogen, argon. They've already boiled. I know sometimes when we think about boiling points in solids and liquids, we just tend to think about water because water is a solid between, under zero, it's a liquid 0 to 100, and then above 100 it's a gas. But you know what? That applies to every object out there. Even the solid pen or pencil you're writing with right now, if you raise the temperature high enough, it's going to turn into a liquid and a gas. So again, the air we're breathing, it's already boiled, so they have low boiling points and melting points. And when it comes to conducting heat and electricity, they do not conduct, which is handy for when you're cooking. You grab the handle of a pan, and thankfully it's not made of metal because you burn your hand. It's made of a non-metal. So let's say do not conduct and electricity. So that is a pretty solid list there. Chemical properties are easy because essentially nonmetals don't react with anything. They're just very non-reactive. If you throw them in acid, they're just going to float around. You throw them in water, they're just going to float around. They are oxygen, so they're not going to react with that. So let's just summarize this by saying, do not act with water, oxygen, or acid. And all those three things are made of nonmetals already. Water's made of nonmetals, oxygen is a nonmetal, and acids are also made of nonmetals. So there is our summary of nonmetals. Now that leaves us with the metalloids. And we can summarize them actually in one sentence. It's kind of a long sentence, but we can get it done with one. Because metalloids are found in between the metals and the nonmetals on our periodic table. So it's probably not a surprise to find out that they're actually a mixture of the properties of metals and nonmetals. And it's all kind of individual. So if you find a metalloid, maybe it's shiny, but it doesn't conduct heat or electricity. Or maybe it's dull, but it does conduct heat or electricity. So it's all kind of specific to the metalloid. So let's say this for metalloids here. Let's wrap this up. Metalloids. They have a mixture of the chemical and physical properties of metals and nonmetals. The end. Okay, so hopefully you kept up with me there. We do have a worksheet to do, and there is actually going to be a quiz today on all this stuff. So let's go back to the website. And if you can see this here, the worksheet is down at the bottom. We'll open that up. And all it is just a brief description, and then you just sort of got to figure out if it's a metal, metalloid, or a non-metal based on the description I give. You don't need to put your name on this. We're not handing this in. In fact, I'll give you guys a little bit of time here. It's only 10 questions. So why don't you guys take, say 5 minutes right now, read through this. We'll come back, we'll take it up, and then we'll proceed from there. So it's 10 o'clock right now. I'll give you 5 minutes to figure these out. Alrighty. So that's about 5 minutes here. So hopefully you got most of this done, if not all of it. Okay, so let's take a look here. So the first one is a yellow brittle substance. Okay, the fact that it's yellow and colorful must make it a non-metal. Non-metal. Let's even try to spell that properly. There we go. Bam. The substance is a gas. Okay, that's got to be a non-metal as well. We are breathing in non-metals. They are gases. The substance is gray, brittle, and conducts electricity. Okay, this one could be tricky. So it's gray, so you think it's a metal. It's brittle, so you think it's a non-metal. Conducts electricity, so you think it's a metal. So it has to be a metalloid. Metalloid. Again, it's a mixture of the properties, right? It's got some that are metal properties and some that are non-metal properties, so it has to be a metalloid. The substance is silver, hard, and malleable. That is talking about, that's our metals. I was just thinking back when we did our note, we didn't include the words malleable and ductile. Those were a couple of ones that they did mention. So it might actually be worth going back to the note and adding those in, ductile and malleable. So stretchy and, so you can stretch means ductile, and malleable means you can bend without breaking. The substance melts at a very high temperature and is silver gray in color. That should be a metal. The substance is liquid, brown in color, and has a low melting point. That would be your non-metals. The substance has a low melting point, is red, and in the gaseous state, so that's also a non-metal. The substance is gray, brittle, low boiling point, and conducts electricity. Okay, so right there we've got two things that are metals, two things that are non-metals. So this must be a metalloid. The substance is very stable, but rusts when it's left out in the rain. Oh, it sounds like a metal to me if it's stable. And the substance is a solid at room temperature, so solid, bronze in color, ductile, and has a high melting point. That's talking about a metal. Okay, so there we go. There's the 10. Like I said, I think we should go back to our note and perhaps put in the ductile and malleable ones. Those are sort of typical words that are often used to describe metals. So I'm going to jump back to there. Hopefully you got a little bit of space. I can just put it in here. So malleable, which means bendy, bend with won't break, and ductile, which means it can stretch without break, stretchy. So before we get to the quiz, and I have the quiz set to activate in about 10 minutes from now, I want you guys, and I'm going to send you a link. So here's what we're going to do. The video we should watch here is on Crash Course. It's about 10 minutes long. The guy goes on pretty quickly, but he does describe a lot of stuff about metals and non-metals on our periodic table here. So here's what I'm going to do. I'm going to send you guys the link and open it myself. You can open it yourself from here. I'll just send you the link in the description.